a little bit. You may have heard that before. That comes from an old television show in the very early 1960s, late 50s, called Peter Gunn, written by the same person who wrote the Pink Panther, Henry Mancini. Learned how to play that years ago, and the challenge is trying to do two things at once on your guitar. That's what I always try to do. Okay, but we're only going to do one thing at a time on the trigonometry. So part 2, we're going to be looking at solving a right triangle, and to kind of look at that. And then the third part of this assignment is, or section, is going to be the applications or the word problems. So a couple of things I need to show you on your calculator first of all, and then we'll study this a little bit more in depth. You need to know how to do an inverse trig function on your calculator to find an angle. So if you see sine inverse, that -1 power is how you write what we call the inverse of the sine. That is not saying the sine to the -1 power. That's just representing what an inverse is. If you took college algebra, you would have learned something about inverses, okay, and they're kind of important. So what this means is sine inverse of 0.5 means that you find an angle such that sine of theta equals 0.5. So you're looking for the angle that would give you a sine ratio of 0.5. Well, first of all, I want to show you two things on the calculator, and we'll learn that a little bit more in depth a little bit later, but a couple things you want to be cautious about. The mode button, and you'll do this throughout the semester, is when you press your mode button on your calculator, if you go down to this line, radian and degree, you've learned about radian, radian and degree measure. You need to kind of, when you're doing a triangle problem, you typically want this to be in degrees. We don't usually use radians when we're talking about right triangles. So I just press enter to highlight that. So now I'm in degree mode. If you want to change it back to radians, you just highlight it and press enter. Okay? Anytime you want to go to a clear screen, if you don't know this quit button, if you go second quit, doing that, that just takes you always back to a clear screen. Okay? So basically, here's how you do this on this. So if you want to do the inverse sine of 0.5, you do this. Okay? You'll see that you have the sine, cosine, and tangent button. Inverse sine is above the sine, so you go second sine, then you put in the 0.5, and then you press enter, and that will give you the angle that you're looking for. So that is 30 degrees. All right? So whenever you're doing an inverse trig function, you're actually looking for an angle. So what this means is the sine of 30 is the same as 0.5. Okay, so if I just took my calculator now and did sine of 30, that would take you back to the 0.5. So you're doing everything in reverse when you're doing an inverse trig function. Okay, so what I want you to do, just do this real quick, is get your calculator, make sure you have it in degree mode, and then just type these in, these 3 in right here, and then round to 1 decimal. So I'm going to pause and let you do that and check here in just a minute. Okay, I'm back. So this is what you should have got. You can see how I typed these in the calculator. Again, make sure you're in degree mode. So inverse sine of 0.25, I rounded that to 14.5. Inverse cosine of 0.5 turned out to be 60 degrees. These are all degrees, too. If you didn't put the degree symbol, be sure you do that. Then inverse tangent was 61.6. So again, what this means is everything's in reverse. So I want you to notice, if I did on this number 3, if I did the tangent of the answer, what do you think you'd get? Exactly, you'd be back to 1.85. So you're doing everything in reverse to get that angle. The purpose of this is when you're solving a right triangle, you have to frequently do this on the calculator to get a missing angle. All right. So first of all, before I go down to example 2, what we're going to learn how to do is we're going to learn how to solve a right triangle. So basically, if I give you 2 parts of the right triangle, you always know you have a right angle. So if I give you 2 other parts, you can always find the remaining 3 parts. So anytime I give you any 2 parts of the triangle, and you already know the right angle, you can find the other 3, but you have to know trig to find at least one of those parts, okay? And that's kind of historically where trigonometry began to develop, is right triangles have a lot of application in construction. So back, 1,000 years ago, it was very useful to find a missing side of a triangle for the purpose of construction. Okay, so to begin with, let's go down. We'll do these two together. So what I always recommend you do, I've given you angle A is 35 degrees and side A is 10. So I always recommend that you start by drawing yourself a right triangle. You can draw it however you want to. Then you want to label the sides and everything. So remember, C is the right angle. A and B are interchangeable. You can call that A and B or backwards. And then it goes like this. Side A is opposite A. So that was given as 10 centimeters. Angle A was given as 35 degrees. Opposite B is little b. Opposite C is little c, like that. Okay? So you always want to get everything drawn out correctly using that standard naming convention we use. Okay? So this one you can start in a lot of different places. The first thing I would recommend that you do is I'd recommend you just start off by finding angle B. Okay? Because all three angles in a triangle add up to 180. See, this is already 90, so that's 35. Okay, now if this is already 90, then these two angles add up to 90. So the way you find angle B is you just take 90 minus 35 degrees, and then you've got what angle B is. Okay, you can use your calculator if you don't want to do that in your head. A lot of times you can do these in your head, okay. So what's that, 55? Yeah, okay. So we have 55 degrees is the answer, okay. Now I'm going to put that in. I'm going to put that in a different color so we got the first part of that triangle. Okay, so we've got 55 degrees. All right, so that would be a good starting point. It's just to find the angle. The second thing would be pick a side, and it doesn't matter which one you use. It's totally up to you. So let's go with side B. Now this is the way I like to teach this is if you want to find side B, always try to use what I gave you. Try not to use what you found, because if you made a mistake on that angle B, it'd mess the rest of the problem up. So I'm going to highlight this. That's angle A. I know this. I want to find that. You want to find an angle and two sides, and there should be just one unknown in here. Now, if you look at this, if you look at angle at 35, this is the side opposite. That's the adjacent. Which trig function is opposite over adjacent? Okay, that would be the tangent. So you would say tangent of 35 degrees is equal to side opposite, which is 10, over b, like that. Now that would give you an equation that you could go through and solve. Okay, so I want to do that like that then. Now what I recommend you do on this is you can just cross multiply this. So that's a ratio. So again, you had tangent of 35 is opposite over adjacent, so it's 10 over b. So if I cross multiply this, I would just go like this. Take that times that, and that times that. So I would get b times tangent of 35 degrees is equal to 1 times 10, which is 10. Now what you're going to do is you're going to solve for b. You want to get b by itself. So what's the correct way to get rid of tangent 35? To divide by it. Okay, so you want to divide by tangent 35. Then you're going to have to go to your calculator. Okay, so anyway, the side B is going to be 10 divided by tangent 35. So this you have to do on your calculator. So we take 10 divided by tangent 35, and then we'll round that off, I think, to 1 decimal. So that side is 14.28, so that will become 14.3. Okay, so I'm going to write B in as 14.3. And I'm going to pencil that in as 14.3 like that. Okay, so that gives us that. Now you have more than one way to do these problems. When you go to step 3, what we need to do is we need to find C. The only other thing we've got to do is C. You could do Pythagorean theorem, or you could do another trig function. Okay, now here's what I'm going to do on this. So watch this real carefully here. So what I'm going to do is I'm always going to try to use what I gave you. So I'm going to circle this, and I'm going to circle this, and I'm going to circle the C. Okay, I'm going to talk it out. Try to develop the habit of using the two things I give you when you write your trig ratio. And always use sine, cosine, or tangent, nothing else. Okay, so what I do is I go like this. If I talk it out, that would be opposite over hypotenuse. Opposite over hypotenuse is which trig function? Okay, good, that's the sine. So you would say sine of 35 equals side opposite 10 over side C. Okay, like that. Okay, then just like the last problem, you cross multiply and solve, and then you'd have to use your calculator. So when I cross multiply, I'm going to go like this. So I'm going to have C times sine 35 degrees equals 1 times 10, or 10. Then divide both sides by sine of 35 degrees. That'll cancel out. And then you want to go to your calculator and then probably just round that off to 1 decimal. Okay. So I'm going to take 10 divided by sine of 35, and then that'll give me the answer to what C is, rounded off to 1 decimal, so that looks like 17.4 is what that side is. Okay, so again, you're forming trig ratios to work this out then. So what we'd have is we'd have 17.4, and again, what I'm going to do is just kind of pencil that in as 17.4. Okay. So that's how you would do that problem. The other thing I want to do, and you just need to watch this, we'll learn about why this is a little bit later. It turns out when you solve any right triangle, you can check it by doing a real simple thing on your calculator. So just watch carefully what I'm doing on this. What I'm going to do is I'm going to pick an angle. I'm going to start with angle A, and I'm going to do the sine of 35 degrees. Then I'm going to divide that by the side opposite. So what I'm doing is I'm formulating, I pick an angle and divide it by its side opposite, and then that'll give me some number. I'm teaching you how to check and see that you're right. Pick another angle, let's go with 55 degrees. So we would go sine 55 divided by its opposite side, which is 14.3. They should be the same, and they are. Okay, they're off a little bit because we rounded. And finally, take the other angle, which is 90 degrees. So if you take the sine of 90, and divide that by the opposite side, which would be 17.4, all of these things should be close to each other, at least within 2 or 3 decimal points. These are accurate within 3 decimal points. Now, when you do this, it's something called the law of sines, which we don't learn until way towards the end of the semester. But that's a real simple way when you solve your triangle to tell you're right. Okay, and it only takes just like a matter of seconds to put that information on your calculator. So that's how you check that. You can pause and write that down if you want to, or you can just remember how I did that. Okay, it's just sine of an angle divided by opposite side all the way around the triangle. That ratio should always be the same. Okay, so that's our first example of a right triangle. So I'm going to move down and do the next one here. So again, just start off by drawing a triangle. I always kind of draw it the same way. That's angle C. I'm going to call that A, and I'm going to call that B. And then opposite B is little b, opposite A is little a, opposite C is C. Okay, then I'm going to fill in what I have, and that's going to be 15.6 for C, and side B is going to be 5.5. Okay, so you got to use trigonometry to find these angles. Now you can start wherever you want to. I would suggest that we just go ahead and find side A, and then if we know 2 sides, what theorem do we use to find the missing side? Okay, we're going to use the Pythagorean theorem. So I'm going to find A, so that's A squared. B is 5.5, so I do 5.5 to the second. I plug in C, so that's going to be 15.6 to the second. Going to need to use my calculator on this. Okay, so when I do that, I'll do 5.5 and then raise to the second power. Okay, and then I'll just write whatever I get here. So that's going to be A squared plus 30.25 equals, and then I'm going to do 15.6 to the second power, and that will give me 243.36. Okay, isolate the a squared so you can subtract 30.25, both sides. Okay, that's going to give a squared, and then I'll do that on the calculator. So I'll take 243.36, and then I'll subtract 30.25, and I'll record that. So that is 213.11. And what's the last thing I do to get a by itself? Okay, square root both sides. Okay, then take your calculator. So I'm going to go square root, and I think I showed you before. The 213 is stored in this memory key represented by A and S. So you can go like that if you want to, and then that automatically plugs that in for you. So that would give 14.5, or 14.6 actually, is what that would round to then if you rounded to one decimal. The 5 goes up to 6. Okay, now what I'm going to do is I'm going to kind of just throw these in as I go. Okay, so that would be probably the simplest way to get that side, is just use the Pythagorean theorem. Okay, now this is where we have to use the trigonometry. Okay, so what I'm going to do is, let's start with angle B. It's up to you what you start with. So I'm going to highlight angle B, and I'm going to highlight the two things that I know. Okay, now you got to talk it out. If you look at this, this would be side opposite over hypotenuse. Opposite over hypotenuse is the sine, so you would say sine of B equals opposite 5.5 over hypotenuse 15.6. And again, try to use what was given instead of using what you found, because if you do that, you kind of sometimes will be off a little bit, or if you made a mistake on what you found, that would throw the rest of the problem. Okay, so really what we do is we do this. So we have, whenever you see this, you're finding an angle, so you use the inverse sine. So what you'll do on your calculator is angle B is going to be the inverse sine of 5.5 over 15.6. And you just do that in one step on your calculator like this. Okay, so again, let me put this over here, and I'll show you kind of what I do. I go second sine to get the inverse to come up. Then I put 15.5 divided by 15.6 in my calculator, press enter, and then that would be the angle in degrees. So that would be angle B is approximately 20.6 degrees. Okay, so we got that. All right, so I'll pencil that in as 20.6. Then we got one more thing to do, and then we're done. Okay, and then the last step is the easiest thing to do on this. Just, you always want to know that these two angles, the B and the A, always add up to 90 degrees, okay, in a right triangle. So what you would say on step 3 is you would just say angle A is going to be 90 degrees minus the 20.6 degrees, like that. You can do that on the calculator. So that's 90 minus 20.6. And let's see, that gives 69.4. So 69.4 will be what A is going to be equal to then, 69.4. Okay. Okay, what's going on? Something's messing up on OneNote. Like I told you, it crashes a lot, so let me open it up again. Okay, so we said that was 69.4. Okay, and then that finishes up the problem for us. So now we've got the triangle solved. We found the other three parts of the triangle. Okay, now I'm going to do this one more time. I've got everything labeled in my triangle, so if you want to check and verify that you're correct, just do this. Okay, pick an angle. Doesn't matter where you start. I'm going to start with 69.4. So if I do sine of 69.4 and then divide that by the side opposite, 14.6, I'll get some numeric value. Okay. Then I pick another angle. Let's do 20.6. So if I do sine of 20.6 and divide by its opposite side, 5.5, then you end up getting that. And see, they're about the same. And then I do the same with C, so I have a 90-degree angle, so I go sine of 90 divided by 15.6. And see, they're all about the same. They're all accurate within 2 decimals, so that's got to be right. Okay? All right, that's close enough. It's a rounding that caused it to be off a little bit. Okay, so that's what you would want to do on that to get that checked. Okay, so we're going to move on, and I'm going to let you do a problem. I think 2 problems on the next page, and then that'll finish up the second part of my video recording, is just solving right triangles. So I want you to go to the next page and then just do these 2, and then we'll kind of move on from there. Okay. Okay, so I'm back. So let's take a look and see what you got. Now, these are the answers to the problem. There are more than one way you can do this, but you just got to get the exact right answer on these. So I'll kind of try to talk through what I did. If you got these, great, then just move on. If you need to pause and kind of look at this, then fine. So what I did on this is I labeled my triangle. So I have angle B and C. Like this. I started by finding angle A. Remember, A and B, the angles add up to 90, so 90 minus 42 is 48. And then I did this. When I did the cosine of 42, so what I did is I said, always look at what I gave you, and then pick what you want to find. So I wanted to find A. So if you look at this, this would be adjacent over hypotenuse, so that's what the cosine is. So you'd say cosine 42 is A over 12. Okay? Now, you could do this in a different way, but this is just the way I elected to do this. If you got the right answer, then you probably did it fine. Then cross multiply, that's 12 cosine 42 equals A. Go to your calculator. 12 cosine 42 is going to give you 8.9. Okay, then what I did was I looked at the 42 again. So I looked at this, then I looked at finding this, and then I looked at that. Okay, so if you look at this, you would have, in relation to 42, that's opposite over hypotenuse, so the sine of 42 is B over 12. Then I cross multiply, so B times 1 is B, 12 times 42 is 42. Work that out on your calculator, you get 8.0. Okay, so again, you may do it in a slightly different way than I do it. There's many ways to do this, but there's only one right answer, and then I showed you how to check. So 48, 8.9, and 8.0 have got to be what the answers are, okay? All right, the next one, I gave you 2 sides. So again, I drew my triangle kind of the way I've been doing. So I have angle A, side A was given as 2.85. Angle B, side B was given as 3.25. I went ahead and started with the Pythagorean theorem. If you know 2 sides, Pythagorean theorem is a simple way to get that. So when I did the Pythagorean theorem, just check my arithmetic, you would get 4.3 for the hypotenuse. Okay, now on the trig part, what I did is I said, okay, let's look at angle A, and let's look at the 2 things that I gave you. Okay, in relation to A, that's opposite over adjacent. Opposite over adjacent is the tangent. So we'd say tangent is 2.85 over 3.25. And then when you do this, this is when you do the inverse. Anytime you're finding the angle, you use inverse. Okay, and the best thing to do is just do, in one step on your calculator, inverse tangent 2.85 over 3.25. That gives you the 41.2. Okay, then the last thing I did was, well, if I know this, I can always remember A and B add up to 90, so I did 90 minus 41.2 to give 48.8. Okay, again, you could have done this problem in a different set of steps, but you would ultimately get these answers if you did that right. This thing had a typo. I don't know if you caught that. That said AB. I was obviously, I think, intending for that to be angle B. Okay? All right, so look over that. Review those if you need to. Remember, you can always pause my tapes and rewind and re-listen. You can't do that in a regular class, so that's kind of a cool thing about teaching this way is that if you've got it, just move on. If you need to review it, stop and review it till you get it. Okay? So different students are going to use different amounts of time on these videos. Okay, so I'm going to go ahead and stop this recording here. This will be the second part that shows how to solve triangles, and then the third part I'm going to record separately and do cofunctions. So you'll have to load a new video to do the cofunctions.